Okay, so in front of us we have a EVGA GTX 1080 Ti. This is the SE Black. This card was sent to me by a customer who asked that I repair it for them. So, like all the broken cards that we get, we want to first start by checking for a short on the base voltage rails. So this is 12 volts and 3.3 volts. If you don't know, the first 3 pins on the PCI Express slot are 12 volts, and we're good. And the if you check 3.3 volts, we start at this notch and we go 4 pins left, and we're good. Okay, so 12 volts and 3.3 volts at the PCI Express slot, it's perfectly fine. Now we want to check the 6 pin and the 8 pin. So for this, we can actually get away with just checking this inductor first for the 8 pin, and we're good. And finally, this inductor for the 6 pin. Again, we're good. Okay, so now that we're not short on the base voltage rails, we want to go over to regular resistance mode and take a resistance measurement of all the voltage rails generated by the card itself. So first, we want to check 5 volts, which is this one here. We should see about 1.3 kilo ohms. There we go, 1.288. Now we want to check 1.8 volts. So this is typically, I would say 850 ohms for a reference 1080 Ti, 750 for some Asus models, and then 650 or so for a lot of P and Y cards. But in this case, we get a rather absurd 1.5 kilo ohms. So normally when I see a problem on a voltage rail, it's usually because it's too low. But as you can see, 1.5 kilo ohms is actually, well, hold on, let's get a better connection. It's actually too high. In fact, worryingly high, if I'm going to be honest. I've never seen anything above a 1 kilo ohm before, so I suspect that our problem is connected to the 1.8 volt rail. Now finally, okay, for the next few rails, we want to check first the PEX rail. This is 60 or so ohms. I go with the 50 plus rule, so 68 is nice. And now finally we want to check actually, I'm going to go with 60 plus for the PEX rail for a 1080 Ti, and now we want to check the memory. Again, I expect to see 60 plus, usually around 75. Okay, so we have a problem. We have 28 ohms on the memory. Okay, so maybe we have a dead memory module? Maybe? Anyways, we're not short anywhere, so we can get away with just plugging in the card. Or at least not short on the base voltage rail. We do seem to have a problem with the memory and the 1.8 volts. This is kind of a weird card. So let's just plug it in and see if we're missing anything. Okay, going over to voltage mode and turning the card on. First, let's check the voltage rails in order, starting with 5 volts. 5 volts, we have that. 1.8. And we have the PEX. And because we have the PEX, we must have the V-core. Well, not must, but should have the V-core. And we have memory and, of course, V-core. Okay, so right off the bat, okay, I can tell you that even though the PCB works, the card is not initialized. Actually, let's take off this thermal pad so it's easier to see. So the way these cards work, these 1080 Ti's, is that by default, they are at 800 millivolts when you first start them up. But after the card gets initialized, this drops to 700 millivolts. The fact that we're still at 800 millivolts tells me that the card is not initialized whatsoever. So for a card that has all voltages and somewhat normal, well, in this case we don't have normal resistances, but all voltages, the standard checks are as follows. So the first thing you want to do is you want to be checking for a resistance, you want to be checking the nanofarad rating of your PCIe capacitor. So in particular, on the back, the first pair of data lines, so I think it's these two here. Anyways, basically, this is the first pair. You want to confirm that these are both 220 nanofarads. If they're not 220 nanofarads, you need to replace them. You know, this is the only pair you need to check for a card that gets detected. If, let's say, the card is incorrectly configured, i.e. it runs at, you know, PCIe 1.1 x4, then you can then move on to the other capacitors. But in this case, you know, we need to check this. The next check for a card that's not detected is the crystal oscillator. It's very rare for the crystal oscillator to actually die. It generates a 27 megahertz signal on both the first pin and the third pin. Finally, the next check is the BIOS itself. So if there's something wrong with the BIOS, you know, if it's, let's say, empty or whatever, or it's just not working, this can cause the card to be undetected. So those are the 3 checks. I have to do this off camera, and in a moment we'll see what I find. Okay, so unfortunately none of my theories have worked out, so I've decided to start doing physical inspection. One thing I've noticed is that this card is actually missing 2 components. I'm not sure, hold on, let me focus. So, it's missing a component over, oh, whoops. Here, and here. I know the one up top is resistor, and the one at the bottom is a capacitor. I'm not sure the values, but given, okay, so I don't know what these components do, but I know at least some of them are used for, let's say, at least resistors on a 1080 around this area would be used to set, say, the memory configuration, i.e. Micron GDDR5X at the, at 11 gigabytes or whatever. So we can take a guess that these are probably pretty important. Anyways, I'm going to replace them. I'm going to, of course, measure them, and then we're going to see if the card is, well, any more functional. Okay, I've made some progress on the card. If we, you may remember that we had some, well, we were missing two components on this area. Well, I installed them, and the card didn't boot. So I decided to take the hint and start looking at the other components in this general area. And as it turns out, this resistor, oh, I'm sorry, hold on, let's focus. This resistor here. Now, on this particular card, before I changed it out, it was an open line, as in we had a broken resistor. I changed it to a 100,000 ohm resistor, and if you're wondering, this resistor, by the way, this one here, actually connects to the pin 3 on our BIOS chip, which is the write protect pin. Now that's not the only thing that's changed, actually. If we go to resistance mode, and we now measure the 1.8 volt rail, you may remember that we had an abnormal, very abnormal 1500 ohms. Well, if we check it now, 855, 860. Perfectly normal for a 1080 Ti, which means that yes, as it turns out, it was the, well, the reason why we had an abnormal 1500 ohm rating before was because we had that one dead resistor on the write protect, connected to the write protect pin of our BIOS. Putting it back, changing resistor to 100,000 ohms drops the, resistance of the 1.8 volt rail to 850 ohms, which is what we expect. So now let's go ahead and plug the card in and see if it boots. Okay, let's boot the card. So you may remember that before we could deduce that the GPU wasn't initialized based off the fact that the vCore was 800 millivolts and it stayed there. Now you'll notice that it drops to 700 millivolts, which means that now the card is actually initialized. But as you can also not hear, there's no beep. There's no beep code for this motherboard's supposed to beep when it posts, and I don't hear anything, which tells me that there's something wrong, either with the card itself or maybe even the motherboard. My motherboard has been acting up recently. So the fact that it doesn't post straight away suggests to me that we might have memory corruption. So I'm going to go ahead and grab a fan so we can cool the die itself, and then we'll just wait a bit to see if the card eventually posts. Okay, so I ran maths on the 1080 Ti. As you can see, we have memory errors on banks C1 and B0. If you don't know or don't have a copy of maths, I have a guide video on diagnosing memory corruption on select NVIDIA cards. You should watch the video if you want to get access to this program. But anyways, we have to replace banks C1 and, what is that, B0? Yes, B0. Let's go ahead and do that now, and we'll see if the card's any better. Okay, so as you saw, we have memory corruption on banks B0 and C1. So just in case you've never used maths or you don't know the ordering or you've forgotten already, the ordering is as follows, going from the top left to the bottom right and going counterclockwise. It is A1, A0, B1, B0, C1, C0. So what you notice is that our two faulty banks are this one here and this one here. Now, you may notice that further that they're right next to each other and they're in the top right corner. I should note that, generally speaking, this is not a coincidence. What you often find is on these older cards, like Pascal, is that because the inductors for the memory phases are in the top right, the modules closest to the inductors tend to die first. Whenever something goes faulty, again, they tend to be the ones closest to the inductors. You often, it's rather rare, I dare say, to see, let's say, the modules on the other side of the board go bad. But next to the inductor is, again, pretty common. Anyways, let's go ahead and replace these two memory banks, and we'll see if the card's any better. Okay, so as you notice, we're zooming in on the card itself. As you'll see, I've taken off the two offending memory modules, or at least what we suspect to be the two offending memory modules. So the reason why we're zooming in on the card is because I have a sneaking suspicion that the problem with this card is not the memory, those two memory banks, but rather the memory controller connected to those two banks. And I kind of have a bit of, I have a reason to suspect this. So one thing I want to note about graphics cards and GPUs in general is that these graphics cards and GPUs, they have like a compound or resin around the die itself. For example, you can kind of it's like a glue substance around here. So the reason why I mention this is because generally speaking, what happens is that as this glue or resin heats up or is exposed to heat, it tends to brown over time. Hold on, let me readjust the lighting. Okay, so the reason why I bring this up is because if you don't know, the memory controller on these GPUs, they're actually at the outer edges. Like for example, the memory controller for this would be probably around here. The memory controller for these two banks would be around here. The memory controller for these two banks would be in about this ballpark over here. So like I said, the memory controller can be found on the outer edges of the GPU die itself. Now, the reason why this is significant is if we look at, let's say, this particular GPU, what you'll notice is that okay, the glue, resin, or compound, or whatever, around the GPU die itself, it's actually quite a bit browner at the upper right edge. This is, again, where the memory controller would be for the two banks that we replaced. This one here, or not replaced, but took off. This one here and this one here. Now, the reason why I bring this up is because okay, so when the compound or glue or resin or whatever browns, it's usually due to, well, the improper use of a heat gun. But in this case, I think this is actually naturally occurring. I think what's happened is likely the memory controller itself at the outer edge of the die has unfortunately become faulty, maybe shorted a little at some transistor, some tiny, 16 nanometer transistor, and likely that what's happened is that in this case, this particular card actually has a faulty memory controller and not faulty memory. But in either case, what we're going to do is we're obviously going to, well, actually, let's just try to take one more piece of evidence. So obviously, I don't want to dismiss the card as dead until I've at least replaced the memory. So what we're going to do is we're going to take a resistance measurement one more time. I should note that normal on this card will be in about the 75 ohm range. However, if we take the resistance measurement again with those two memory modules off, it should rise. And yet, in this case, we have 60 ohms. You may not think very much about, the 20, 15 ohm difference, but in this case, I suspect that it's actually a telltale sign that we have, like I said, a dead memory controller. But anyways, enough with the, flaffling. Let's go ahead and replace these two modules, and we'll go ahead and stress test, well, not stress test, but rather test the card. Okay, so as you can see, I reran mats. Just to be clear, I did not reinstall bank B0. That's why there's so many errors. I just left it off, and that's because I wanted to test it with just bank C1 replaced. So to be clear, I did replace C1 with a known working module, and as you can see, we still have errors. In particular, if we look at the failing bits, they're exactly the same. To make this even worse, we also now have errors at F0, where previously we didn't. And then to make this much worse, you notice how they're in the same proportion? That's because these errors are of the data bus inversion type. So you can see how you have 000s and then FF. This is a data bus inversion. This is generally a scary type of error to have on your memory, as it is often, I wouldn't say often, but I would say disproportionately often the result of a dead or faulty memory controller. But anyways, so unfortunately, it seems like this video is going to be a diagnosis video. I don't believe changing any of these modules would, and of course replacing this one, would cause the card to suddenly become, well, usable. So, because of this, I have to tell the owner that the card's dead. In either case, though, I hope you learned something watching this video, and hopefully I'll see you in the next one.